In this video we'll show you how we can machine the basic drawing which we created previously in the CAD system. In one of the previous videos we showed you how to create the contour and transfer that through to the CAM system. So having done that, this is the screen that we are presented with. This dialog box is the machine setup, and this allows us to set the machine type. Well, we've already chosen that it's a milling machine, so we can leave that. The program ID, what we can enter here is we can enter a program identification or a part number, for instance. The NC program number would normally appear at the top of the G-code file, but depending on your controller that may or may not be necessary. Under the tool change position we need to check that the values here are correct. The system has two positions that it can move to. The firstly is the home or the safety position. So this is where the machine tool will start from and where it will end up. And then another position is the tool change position. On some older controllers you need to move the machine to a specific XY location for the tool changer to work. But on most modern machine tools and on manual machines it's simply a question of moving to the Z safety position. So either of the positions here for the tool change or the home position can be XY0. What they shouldn't be is they should never be Z0. Z0 is the top of the job, so you don't want the machine rapiding to the top of the job when it's changing tools. So make sure that the tool change position here has got some good values in it. The clearance plane is a position above the top of the job which is clear of any obstructions, work holding, clamps, fixturing, etc. The feed change plane is a height above Z0 where the tool will change from a rapid to a feed rate. The tick boxes at the bottom here will depend very much on your controller, whether you have to force a spindle stop and a coolant off before a tool change, or if a simple T1 MO6 will do that for you. So we click OK. So the way the screen is laid out here is on the right hand side we have the status panel, and as the tool is moving on the screen it'll show us the position. The main graphics area in the middle shows us the geometry, and that's where the toolpath will be shown. On the left hand side we have a window which shows us any contours, and below that we have tooling definitions and program operations. So in most cases when you first start off using the system, the tooling definitions window will be empty. When you've defined tools, the system will automatically save them away for you. We could also use an existing tool file, which I'll show you how to do in subsequent videos. So the way the screen is laid out is that we've got two toolbars at the top. The top one is the global operations, saving, opening and so on, and then how the screen is viewed. So this is where we set up the different views and then the different ways of drawing the tool path. We can use tool animation, tool envelope or tool centerline. So to start with we'll just go into the plan view and we'll switch off 4 windows. So to start populating these tooling definitions and program operations windows we use the bottom toolbar here. The setup dialog box was the one that was presented to us when we first went into the system. If we need to go in and change any of that or check on something we can simply click. To define a tool we use the define tool dialog, and here we need to set up the type of tool it is we're using, and then for that tool we need to give it the parameters such as the diameter, length and so on. So if we choose a standard end mill to start with, we set the diameter. The lead is not used on an end mill. The length of the tool is shown by this graphic here, and it's merely a visual representation. It won't have any effect on the actual cutting that you do. The tools that you set on the machine at the moment are set exactly in the same way. The tool number and the tool description can be entered here. Click OK. So that's put a tool in the tooling definitions window. If I want to change that, I double click its entry and I can change any of the parameters. So that's defined a tool. Now we need to select that tool for use. So to do that we use the M6 command, which is do a tool change. The tool that we're going to use, there is only one tool loaded, so that's the one we'll use. The radius and length offset registers, we can leave the defaults because they will be the same as the tool number. The spindle speed, we can set the spindle speed that we want here. The direction is pretty much always clockwise. Then we have two feed rates. The principal feed rate in X and Y can be expressed as feed per minute or as feed per rev. And the Z-axis feed rate, again, if we were using feed per rev, then that window would be open to us. But normally for milling cutters we're using feed per minute. If we need to switch on the coolant, then that's how we do it here. So that's selected that tool. So over on the right hand side, the status panel shows us the tool in its current position. This is the tool which is being used, and the spindle speed and feed rate are set. So now we need to choose a machining option for this shape. So in this example we'll use the go round command, which is for basic contour machining. So the first thing it needs to know is the name of the contour that we want to machine. Now in our case there is only one. If there are multiple contours you could choose them from the pull down list, or you could choose them with the cursor. The Z planes that have already been set, the feed change plane, the default is 3 mm from the setup dialog. The work surface is 0 and the depth of the contour is 20. These values came from the drawing. When we created the contour we gave it these values, but if we want to change our mind we simply put in new values here. The direction of cutting can be forward or reverse. If you remember in the previous video when we created the contour we had the start point as the bottom right hand corner and the cutting direction was to the left, so that's the forward direction. To cut the tool on the outside of that would be left of that line, but if we want to change our mind we could cut reverse, or we could offset to the right, or we'd have no offset at all so the tool sits on the line. If we want to leave finishing allowances, this is where we set them up. Other options include the approach and go round, which we'll leave the defaults as they are, and then we'll go into more depth about these parameters in subsequent videos. So that's showing me the toolpath on the screen. If I just use the mouse wheel to zoom in and out, the tool starts off at its home position, which is 0. It rapids to the first position here, shown by that dotted red line, and then goes down to the depth. The blue line is the center of the tool. So that's looking at it in the plan view. If I want to view just the tool center line, I click center line and run the job. That just shows me the center line of the tool. The tool envelope will block out the tool so I can see the tool diameter. Switching off all of those options just gives me the tool diameter and the center line. If we want to view it in the ISO mode, then we can do here, again using the mouse wheel to scroll in and out, and then we could animate the tool. So the tool now comes in. This shows me the rapid motion from the safety position, feeds down to the required depth, and then applies the approach movement, machines all the way around, applies the runoff, and then retracts the tool back out. So in its simplest form, that's how the CAM system works. We create a piece of geometry in the CAD system called a contour. We pull that contour through into the CAM, and then we produce the machining on that. The last stage in the process would be to post-process that, which produces the G-code file, and to do that we use the icon at the top right of the screen here, and we choose the post-processor that we want to use. My default is a HASS, but there are quite literally hundreds of different post-processors for different machine tool and controller combinations. When we post-process, it takes us through and reruns the job just in case we've made any changes. When that's completed, we get an information panel telling us that the file has been produced, and then a window is opened up at the bottom of the screen here, and if we just stretch that out, these are the G codes that have been produced, which we can then send to the controller. If we have a DNC link to the machine tool, then we can send that file directly from the CAM system. Under File, we have an option to send the NC program to. So if you've got an RS-232 link, you can send the program directly from the CAM system here. So that finishes this video. In the next video, we'll show you how the simulator works.